Welcome, everyone. Hopefully that was a good break. I am Brent Langston. I have to look at the slide to remember what my name is. I work on the containers team for AWS. So my job is developer advocate. And that means I go around and I talk to startups, I talk to large enterprises, I talk to developers, and find out how are they using containers, what are their pain points, what can we do to make their life easier. I especially identify with developers because, well, I've been one. I've been in the SRE world. I've been a developer. I've been an operations person. I've helped build Tumblr, Spotify, Cloud Passage, and HighOscar.com, which is a healthcare startup out of New York City. So I've been doing this for a little while, and I've been using containers, not the whole way, because they weren't that popular, but as soon as I started seeing what the possibilities were, especially around packaging software, I really got interested in it. It made my life a lot easier. It made the lives of my fellow developers a lot easier. And so, I sort of developed this keen interest, this passion around containers. So joining the containers team seemed like a natural fit. So in this talk, what we're going to be taking a look at is what are the various components available to you if you're using ECS? A lot of times ECS gets compared to other orchestrators. Used to Docker Swarm. I can run Docker whatever on my laptop, and I can put that on an instance. So, how does ECS make things better? Today, Kubernetes is quite popular, so we get a lot of comparison questions about Kubernetes. There's also Mesos, there's also Rancher, and things like that. So, what I want you to understand at the end of this talk is just what is the ECS ecosystem like, and what do you get with it. Does anyone here use ECS specifically today? Raise your hand. Awesome, not very many. So I think the vast majority of you guys are in the right room. What do you use? Just call out, what do you use to orchestrate today? What's that? Kubernetes, okay. How about, is anyone just using their config management tools, maybe Chef or Ansible, and you are launching, I see a hand in the back, you're launching containers, on a per instance basis, maybe instance types. Yeah, this is very common roadmap. You start off with config management, configuring instances, and then you move on to using that same config management to create instance types and then launch specific containers on those instance types. And you can go pretty far with that. When it comes to then doing a deploy, the next version of your container, however, what you'll run into is, you have to go make a config update. A Chef change or some kind of new parameter passed into an Ansible playbook or something like that. It's not impossible. It's certainly even probably considered easy, but it's not super developer friendly either. So one of the things that containers has sort of brought to the table, along with easy packaging, is easy deployment and being able to put more tools for deployment back into the developers' hands. So the developers can more or less deploy whenever they want or as their code changes. It means they can do a lot more testing, they can do a lot more sort of trial and error, and they can push out code faster, and they don't have to necessarily involve the global config management system and get approvals and that kind of thing. So in this talk, we're going to be taking a look at using an orchestrator. I highly recommend using any orchestrator over config management. It's the next evolution of sort of the road that you're on. Not that you've done anything wrong. I think it's great, but now you see what the limitations are. So moving on to an orchestrator is certainly useful. ECS is a very popular one and available to you for free at AWS. So we'll be looking at how to do deploys, how to ensure availability, cost optimization. We'll look at the options that you have available to you. We'll be looking at scaling, and then we'll be looking at monitoring and logging. So we're going to go through all of these and hit each point and sort of show you an example of this in action. At the end, I'll point you to a website that hopefully can recreate a lot of this for you and let you have kind of a sample application and a sample cluster that you can poke at and try out all this stuff. And then you'll be able to go and emulate that with your own code at your own pace. Okay, so what are some of the key components of ECS? ECS is our orchestrator, but what else is there? It's one thing to just say, with RDS, for example, if you're going to use RDS, what do you get? Well, you get a database, and you get to pick a flavor, but ultimately you're getting a database, right? And everyone knows how to use a database. With ECS, on the other hand, you're just that's the starting point. You're getting an orchestrator, but you should pair that with additional components. And so knowing what those components are is super useful. ECS is a control plane. There aren't versions of ECS, so if you're familiar with Kubernetes or any of the other orchestrators, when you launch them, there's a master control plane, and then there's a data plane, which is where all of your containers run. You manage both. And then anytime there's an update that comes out, it's on you to perform that update. And depending on the orchestrator, the procedure for that can be complicated, involved, or maybe simple. But there's a procedure nonetheless. With ECS, there is no update. There is no new version. We update the version in the background, and you are always just using whatever the latest version of the control plane is. So we're just providing you an API, and you are telling us through task definitions how to deploy which apps, where, how they need to be secured, and stuff like that. And then we, through our control plane, will talk to your clusters. So your clusters are the data plane. You bring instances, and you configure them to be part of an ECS cluster, and then we are able to, through the agent, able to talk directly to those instances and instruct them on which containers to run where. If we see that a container has died, we'll relaunch it, etc. Of course, you heard about Fargate. So Fargate is the option that you have available to you for not managing the data plane either. So with ECS, you never manage the control plane. You don't have to worry about it. And now you don't have to worry about the data plane either. And again, think about updates. What was the exploit that just came out a month ago? That I can't think of the name off the top of my head. It just left me. Everyone had to update their instances, had to do kernel updates, had to do new patches of software, update AMIs, etc. So when that was announced, it was days of work for companies. With Fargate, for example, we simply patched for you. And so when you launched your next round of containers, maybe it was just your next deploy, suddenly you were protected again, and you didn't have to do any work on your own. So having a managed data plane can be very useful. The way I like to think about it is if there's something that allows me to get a competitive edge by me running whatever myself, then I'll do it myself. If, on the other hand, I can't gain a competitive edge by running my own instances, running my own operating system, then why bother? It's just extra work for nothing additional. I want to focus on running my application. I don't want to focus on running the operating system and making changes at the operating system level. So I tend to favor Fargate. However, if there's something that you need, maybe it's GPUs. You need to be able to make fast calculations, and the way you've coded your application, you can take advantage of GPUs. Well, that's going to give you a competitive edge. Run your own instances. With ECS, every cluster is a hybrid cluster. So you can launch Fargate tasks, you can launch EC2-based tasks. It doesn't matter. They're all in the same cluster. They can all communicate with each other. So when we're talking about components, the ECS component, it's good to break down, like what do I have to do and what does AWS do for me. So I have a few slides on this for the various components, and you can see what does AWS take care of at the top, and then what do I have to take care of at the bottom. And what I want is for the stuff at the bottom to either not exist, I want to minimize the things that I have to do, or I want those things to give me some competitive advantage, right? So when it comes to ECS, the control plane, AWS takes care of all of the security for it, patching it, making sure that it's updated. It does all of the monitoring to make sure that the service itself is healthy, it is highly available, it scales well, and of course, we're paying for it. It's no extra cost for you. What does that leave for you to worry about? Deploys. It means that you are out there ready to trigger a deploy of your next version of your application. So that's something that, rolling out updates, that's a competitive advantage for you. So definitely, this is the right balance. For ECR, we take care of monitoring, availability, scaling, patching. You take care of, again, deployment, making sure your images are pushed, the cost control. You pay based on the space that you take up. So we give you tools. Lifecycle policies is one tool that we launched in 2017. We give you tools to help you manage that space, but ultimately it's up to you to decide, I want to pay for this much or I want to pay for that much. And you can clean out images as you're willing. And then, of course, security. We provide you with RBAC, we provide you with IAM integration, but it's up to you to create those linkages and specify that this instance is allowed to talk to that ECR repository. The container instances themselves, this is again where you will have the most responsibility. You can build your own AMIs. You can use a pre-created AMI that we provide you, but ultimately nearly all responsibility for this layer is on you. So you deploy these AMIs, you patch them, you scale them up or down, paying for them and managing those costs is up to you. Monitoring, availability, security, all up to you. So this is where the most work for you exists. Now, when you think about every other orchestration platform, there will have been more work on the other slides for you. This would still be the same. With Fargate, how much of this goes away? I mean, think about that. When it comes to paying for Fargate, factor in that most of these responsibilities go away, and you don't have to worry about them anymore. So container instances, we do provide you building blocks for managing your responsibilities. So when it comes to deploying, of course, you can use CloudFormation. Infrastructure as code is highly recommended. The way that we do it natively is CloudFormation. You can also use Terraform. You can use Chef. You can use Ansible, Salt. All of those are at your disposal. They all make use of the SDK. So you can write your own if you want. I've known people who write their own Go apps to launch resources. So that's certainly up to you. Security, for RBAC type applications or RBAC type access, we have IAM For auditing, we have inspector. For analyzing, we have VPC flow logs. And then we have additional security offerings. Everything that is available through EC2 or to an EC2 instance, you can do with an ECS instance also. Patching, the standard practice is to update your AMI and then roll out new AMIs. Has anyone ever heard of immutable infrastructure? Really? Only 3 hands? Okay. So immutable infrastructure doesn't mean that your infrastructure is read-only. What it really means is that you don't mutate your infrastructure. So as you are using your instances, if there's a change that you need to make, you don't go to each instance and make that small change. You bake that change into a new AMI, perhaps, and then you launch new AMIs and replace the old AMIs. The great thing about that is everything is completely replaceable from 0 to where you are. I don't know if you've ever been using, I pick on Chef for this a lot because I've used it in the past. I've used Puppet too, but there are times where you get to a point where whatever you did years ago, you can't do anymore, so there's no way for you to start from 0 and get to current. You have to, it's very difficult to do it in an automated way. So there's always like these weird hoops that you have to run through. I remember at Tumblr, we used to have to run Puppet 3 times because there's nothing magic about 3, but one time didn't usually get all the work done, and the second time would get more stuff done, and then the third time would finally get everything done. I see people smiling. I know that they do the same thing. So this is not that unusual. But if you're using a process for immutable infrastructure, this is not likely going to be your problem. So what your problem is going to be is, how do I manage rotating out all of my instances? How do I do it in a safe way? And how do I do it slow enough that it doesn't damage my application, but fast enough that I can respond to some kind of security issue in a reasonable time frame? So we give you, of course, all of the tools that you need to do that kind of stuff, but it's still up to you to do it. For monitoring, we have CloudWatch. CloudWatch is native to the AWS platform. You can monitor all kinds of services with it. So it stands to reason that this is the best case monitoring solution for you. And then scaling, auto-scale groups. Again, it's just like you'd scale EC2 instances. You can scale ECS instances. There is something that is nice when you're using ECS. When you're using ECS, what you care about from the instance perspective, you care about CPU and memory primarily, and then occasionally you'll care about disk space. Most of the time you're running stateless applications, and disk space doesn't really matter. But occasionally, like I've seen a bill processor, for example, that creates a bunch of PDFs. So the application itself is stateless, but it writes out files that it then mails out. So there is some sort of ephemeral state necessary. So disk space is important in that case, but if you're a web service or something like that, then it's probably not necessary to care about disk. What you care about, though, then is CPU and memory. Well, CPU, for Docker and for all the orchestrators, you're able to overcommit. So the possibility of you running out of it is low. I mean, you can still run out of it, but you'll know well ahead of time because you can overcommit. You can't overcommit on memory, though, so it's not uncommon to run out of resources, and the first resource that you tend to run out of is memory. So one tip, pay attention to your CloudWatch alarms and your memory utilization and auto-scale based on memory. And then, of course, cost control. You can do spot fleet. You can do reserved instances. Okay, so tasks and containers. When it comes to running your application, you build a task definition. And the task definition you then provide to ECS, and that describes the task that you want to run. You can then also couple that with a service definition, and the service definition describes how you want to run that task. So the task definition might be, I need to run this container and maybe this Nginx container as a sidecar. So my web application and Nginx application. The service definition then might be, I need to have at minimum 6 of these spread across 3 availability zones. And ideally, not even sitting on the same instance. So if I have 3 instances in each of the 3 availability zones, 9 instances total, if I launch 6 containers, I should end up with 6 instances, each running one of my task definitions. You guys follow that? If not, come back for the afternoon session on advanced scheduling, and that's exactly the kind of thing we'll be looking at. Okay, so deployment. What are the options for you to build your task definitions and get them running on ECS? Of course, there's the console. If you're just starting out, I highly recommend using the console. It steps you through the required information and shows you the optional information. It has help. It has some details. So this is how you learn what you need to provide, what you need to know, and what you need to tell us. However, this should not be what you do for production. So if you're building development, this is great. This teaches you. But then once you've learned the items that you need to know, move on to doing something that's a little bit more reproducible. Even if it's scripting, at least that's something that's reproducible. Save your steps in a script, be able to rerun your script. You can also take a look at Terraform, CloudFormation, or any of the similar products, and be able to reproduce your environment. The environment that I built most recently is completely reproducible, running one command. It's actually through our Jenkins server. We would push a button, fill in the developer's name, and the developer would get their own environment built for them, start to finish. It took about 20 minutes, but doing it by hand always took way longer. So automating and building out using code is definitely highly recommended. So by using code, your deployment will be repeatable, it will be auditable, and then it will be self-documenting. As long as someone is able to read the code, they'll be able to understand what's going on. So you don't necessarily have to write a large volume of documentation to explain every step, because today's tools, especially something like Terraform, is super easy to read. So you just start at the top, read to the bottom, and you can have a good understanding of what's going on. CloudFormation is the built-in language of AWS. So this is very hard to read, sorry. You'll be getting a copy of these slides, so don't worry about it. And in fact, there's nothing super critical on this slide for you to understand, but just know that it's documenting, it's self-documenting. So there's a description for every single section, and you can see the parts that will be built. Okay, so now it's time to deploy. Down at the bottom, you can see that we are running create stack. So we're using CloudFormation, and we are creating a stack that's found in this file. So the last file that we were just looking at describes the stack, and then we're going to pass that into CloudFormation. CloudFormation, on our behalf, is then going to go and create all of the resources at AWS. It can create VPCs, subnets, routers, NAT gateways, security groups, all the things that you need. It can launch instances, create autoscale groups, everything that you need to be able to launch an ECS cluster, CloudFormation can do. I do absolutely everything through CloudFormation. When you want to update, maybe you've made a change to your stack, the .yaml, so you can just run update stack, and this will sort of analyze the parts that are the same, find the parts that have changed, and then go out to whatever component you've changed and initiate that change at AWS. When you need to create a new environment, because you aren't making tiny changes that get you from point A to point B to point C to point D, you're making changes to the whole stack all at once. All you have to do is create stack, right? And launch it with a new parameter, but use the exact same template that you used before, and you will get a current copy of the stack. You don't have to then enumerate each change after that. ECR. So from the command line perspective, you can just run create repository, or CloudFormation perspective, you can create an ECR repository. Does anyone here use ECR today? I think there was a Datadog survey, and ECR is now the second most popular. It's the first most popular private repository, second most popular repository, period, right behind Docker Hub. So I would expect Docker Hub to be the biggest, obviously, but then it's interesting that ECR is right behind it. So with ECR, we integrated it with IAM, but we need the native tooling to be able to actually authenticate. And the native way is Docker login. Docker login just uses simple username and password, but we wanted something a little bit more stringent. So what we do is we integrate it with IAM, and then IAM will issue you temporary credentials that are good for 18 hours, I think. I can't remember exactly. So you can get those credentials by running AWS ECR get login. The syntax that you see up on the first line here is using bash command substitution. So basically what we're doing is launching a new shell, running AWS ECR get login, and passing the output, which is the Docker login command, to our current shell. So we're running Docker login and the long username and the long password in our current shell in an automated way. After you've done that, you're authenticated to ECR, and you can run standard Docker commands, Docker pull, Docker push, etc. If you want to automate this credential handling, we actually have an ECR credential helper that you can launch on your instances. So that will take care of grabbing those IAM credentials for you. So building your ECS cluster, again, the command line way, AWS ECS create cluster, or the CloudFormation way, ECS cluster, and then you just give it a name, pre-prod, if that's what you want to name things. The container instances. This graph is kind of scary looking, I think, but I think if you've ever used EC2 instances and you've ever built your own VPC, you probably only are shocked a little bit, and then you start to look at it. It's normal. It's what it looks like. So what we have are this is a VPC, and inside the VPC we have two availability zones. I tend to prefer 3, but this is just showing us 2, probably just to keep it less scary looking. We have an application load balancer. We have NAT gateway endpoints in each of our availability zones, and then we have our instances. I think the only thing that I would point out here that took me a while to realize, there are public subnets and private subnets. Just in the back of your mind, file away, I never put instances on public subnets. I only terminate load balancers and NAT gateways and other things that need internet access. I terminate those on public subnets, and all of my resources go on private subnets. So that's what this graphic shows us here. The instances are all on private subnets. How do they get out? They get out through the NAT gateway. So they have to route to the public subnet and talk to their NAT gateway, and then the NAT gateway lets them exit. And then how does traffic get into them, into the applications? Nothing talks directly to the instance in this arrangement. That's the beauty of it. You don't have public IP addresses on your instances. So you have an additional layer of security that way. So how do you get traffic in? Well, you route it through the application load balancer. The application load balancer receives the traffic and then turns around and sends it to the correct container. So now you can have container workloads that are publicly exposed running right alongside container workloads that might not take any inbound traffic. So, there might be some batch processing happening right alongside your web front end. Because of this, you're able to take advantage of increased densities. You're able to save costs by running fewer instances. And then your instances are even more common. You don't have special instances that are in public subnets and other instances that are in private subnets. So I think this is just kind of going over what we looked at. Inbound traffic comes in through the application load balancer. That's the only path that traffic has to come in. So we can do additional things this graph doesn't necessarily show, like route our traffic through a WAF. We can use a web application framework, and we can ensure that the traffic that's coming in is genuine, has the correct fields filled out with the correct, with the expected inputs, and then pass it into our application. We can do all kinds of cool stuff like that. And then for outbound traffic, we go out through the NAT gateways. And from this, if we want to, we can use VPC flow logs. We can analyze what's able to exit, et cetera. If you're in a regulated industry, maybe you actually want to control the traffic that is going out and only allow certain kinds of destinations. So you could replace NAT gateways with proxies. And then you can, have very advanced filtering set up for the outbound traffic and where it's allowed to talk to. For logging, we have a great service called CloudWatch Logs, and we have deep integration directly with CloudWatch Logs. So you can have all of your container instances logged directly to that. And I'll tell you, here's what I tell developers. When you're building your container, log to standard out. Don't try and get all fancy and set up logging to a syslog server or anything like that. You're in a container for a reason. Containers are uniform. So every application should just be written to log to standard out. Then what we can do is we can take those standard out logs from your container and we can ship those wherever we actually want logs to go. That might be a syslog server somewhere. That might be CloudWatch logs. It might be FluentD to some other elk stack or something like that. There's all kinds of options, but it all starts with log to standard out. So just as a developer, be in that habit. If you aren't the developer, but you talk to developers, teach them, log to standard out in your container, and life should be good after that. Now, if you want to see some reference architecture that sets all of this kind of stuff up, check out our AWS Labs ECS RefArch CloudFormation, and this is CloudFormation that will build an entire stack for you. Okay, so let's build an application. This is a hypothetical application. You can go away after this and build this if you want, or you can just apply these concepts to your own application. So our application is a tweet collector. So think about what we need. We'll need some kind of thing that will go out and read from Twitter. We'll need something that will write tweets that it collects into our storage. And then ideally, we'll actually have some kind of pipeline set up so that we don't lose data if anything should ever go wrong. We build for failure. So if our tweet collector finds a tweet, we don't want it to necessarily pass it straight to a tweet archiver, because what if the tweet archiver is down? So how do we deal with that kind of failure? So we're going to do that with Kinesis Firehose. We're going to write our tweets into Firehose, and then from there, we can actually set Firehose to log directly to S3. We can also have the ELK stack, the AWS Elasticsearch service, as a target. And then we can process these tweets real time using AWS Lambda. So we can do all kinds of cool things with it. So there is a microservice and RPC framework that Twitch created. If you do decide you want to write this, definitely check out this RPC framework. It basically lets you use RPC for talking between your microservices. So this, instead of using REST, this just makes it a lot easier for you to pass data from one service to another. Again, a little bit hard to read, but basically you can write a spec on the data that you're going to be passing. You can generate a client and a server for that data, and then pass the information from service A to service B, from our collector to our archiver. It's limited to Go for today, but there should be more languages supported later. So the tweet collector. This is, by the way, available on GitHub, so if you wanted to run this, read it, edit it, whatever, you're going to be able to do that. Again, links will be provided in the slideshow. So it's written in Go. It uses the Twitter API, and it takes as environment variables search terms that you're going to be looking for on Twitter. Anything that it finds, it's going to then write out to its archive endpoint. For you to be able to run this, of course, you'll need to attach an IAM role that allows it to write to that archive endpoint. The archiver, again, also written in Go, hosts the RPC server that the collector talks to, and then it sends tweets to Kinesis using the AWS SDK. So its environment variable is basically the Kinesis stream name. So these two things together will collect and then write every tweet that matches your search term. What might you want to, or what might a developer workflow look like with this? You can run it locally, and you can have one container talking to the next container, do all of your testing. It logs to standard out, it logs to standard error. It can use your local AWS credentials for talking to Kinesis Firehose. Once you have this up and running locally, if you think, okay, I'm ready, push it. So the containers themselves, because they're containers, the way they run on your laptop should be basically the same as the way they run in production, with the possible exceptions being what environment variables you pass in. So you would deploy to ECS with CloudFormation that is provided. Logs, because they're going to standard out and standard error, we collect those and we ship them on to CloudWatch logs. And then you would need, of course, the IAM role for talking to the Firehose. So instead of your local AWS credentials on the left, you'd be using an IAM role on the right. And then you'd have metrics available to you for the container runtime in CloudWatch. This project, this is the URL for it, so if this sounds like something you want to try, definitely check it out. If you want to take it further, remember we mentioned real-time processing with Lambda. You can actually pass in every time we archive to S3, that can trigger a Lambda. And so this Lambda, you can do something cool like sentiment analysis. Is this tweet positive or is this tweet negative? So maybe you're searching for your company name or your company hashtag, and you want to find out, like, am I overall receiving good tweets or am I overall receiving bad tweets? At one of my startups, we were small enough, we were just getting started, but we actually had a dashboard on our screen at the office that was number of days since a negative tweet. And if we could go 30 days, then we would have a party. We always looked for reasons to have parties. So we made it once, it was awesome. But yeah, it's sentiment analysis is pretty cool for doing little things like that. What else do we need for production? Well, You've built all this infrastructure. How do you know how much am I spending? Am I able to do this cheaper? So cost optimization is something that I personally find very exciting. I love being able to build something and then start to crank it down and make it as small as it can be while still having all of the functionality that I need. So 2 tools that you can use to make this happen. 1, reserved instances, and 2, spot pricing. By the way, auto-scaling, I should have mentioned. 3rd tool, scale up when you need to have a lot of capacity. Don't forget to scale back down when that capacity subsides. So if you're an e-commerce site, Black Friday is very popular in the US. Scale up, auto-scale, and then scale back down when the traffic subsides. But even more than doing that, reserved instances. Does anyone here already use reserved instances? Few hands, okay. I like to describe this as handy but complicated. There's there's sort of a graduation of savings that you have available to you. You want to prepay for everything up front, your savings is bigger. You want to commit to 3 years, your savings is bigger. You want to prepay nothing up front and only commit to 1 year, your savings is smaller. But there's still savings. So it's nice to be able to have that kind of flexibility. And then, of course, if you do this, you still can scale up and pay on-demand pricing for anything that you didn't pre-plan for. So I would set reserved instances as sort of a bare minimum. I know I'm always going to have 30 instances, but sometimes I need 300. So, those rare occasions when I need 300, I'm paying on-demand pricing, and hopefully because I'm getting all that traffic, it's paying for it. It's covering my costs. If I'm an e-commerce site, I'm making huge sales. That's awesome. If, on the other hand, I need to go from 30 to 35, I'm not paying that much more. I'm still, seeing a decent cost savings because I've done reserved instances for the vast majority. Now, what I actually prefer to do, I like flexibility, and reserved instances tend to lock me into at least a year commitment. So what I really like is Spot and Spot Fleet. Does anyone here do spot-priced instances? Very few. Okay, cool. So let me tell you how spot price works, the spot market. If you are, for round numbers' sake, let's say that you like to use instances that cost $1 an hour. So the only problem is you don't want to pay $1 an hour. That's a lot. So spot pricing gives you the option of bidding less money for that same kind of instance. And if we have excess capacity, then what we do is we rank all of the bids, starting from the highest bid to the lowest bid, and then we take all of our capacity, our excess capacity, and we start to fill those orders. So if you bid, I personally like to bid the on-demand price, so I'll bid $1, even though I'm hoping to save money. What happens is, as they reach my slot in the rankings, if I get an instance, great. I have that instance for an hour, and I get to run my workloads. When they reach the bottom, whatever that last person that got an instance bid, that's what everyone pays. So if we get down to the point where this person bid a dime for $1 instance, then great. Everyone that got an instance pays a dime an hour. So you get to save a ton of money by doing that. I always do this for workloads that are not user-facing, not customer-facing, so not my front ends. Batch workloads that I can manage to go a few minutes without. And then I even consider doing this for front-end workloads, depending on the application. So my last company, we ran 100% on Spot. And there's a second sort of verse to this that's called Spot Fleet, where you can actually say, all I really care about is getting CPU and memory. I don't care what instance type, or I have a variety of instance types that I can spread my load across. So by doing that, I am unlikely to be outbid on all the instance types that I can possibly use. So I'll use older M2 instance types. I'll use C3 instance types. Stuff that a lot of people don't tend to use these days. I'll bid on those. I'll also include C4s, C5s. I'll have a very wide variety of instances that I'll bid on. And I'll bid whatever the market rate is. Generally, there will always be something for me. And so even if I get outbid on C5s and I lose a C5 in an availability zone, that's no big deal. Those workloads, those containers, they can die off. They'll get replaced by ECS. That's the beauty of containers, right? You can bring up replacements in a few seconds. So because of that, I can go a few seconds with capacity shifting around from one instance to another, and I can get, between 60 and 90% savings. So that's the beauty of spot pricing, and it lets you be super flexible and you aren't committed long term. I think I just said all of this. Okay, so multiple ECS clusters. Because ECS itself doesn't cost you anything, from the control plane perspective, having multiple clusters is also handy and doesn't cost you anything. So you're able to build a cluster for a development fleet and then build a different cluster for production. And you can pass in, different environment variables and stuff like that, based on am I running in production or am I running in development? In production, I might need 6 of a front-end application. In development, I might only need 1. Because of that, I might need fewer, smaller instances in my development cluster, all spot priced. And in my production cluster, I might need a few more bigger instances to handle the extra capacity. And maybe there I'm very conservative and I pay on-demand rates. My last job, we built out ECS, and every developer got their own cluster. So they were able to push code, they were able to tie it to their own code branches, and then as they committed, that code automatically got deployed out onto their own cluster. And then from a product perspective, our product team would want to see the application, the additional feature that they've added. They want to see it live, so everyone would have their own endpoint that they would be able to connect to and see what was this developer working on. Just go to brent.dev.mycompany.com, and the product team would be able to get in and poke around and see, yeah, this looks good, approved, and we just ship that container. Scaling. So scaling EC2 or ECS instances automatically, you can use auto-scaling groups for this. This is the best way to do this. Auto-scaling can be based on CPU utilization. It's always based on a CloudWatch alarm. The CloudWatch alarm can be CPU utilization, memory utilization. I like the memory utilization one. It could also be just some random, custom CloudWatch metric that you've started shipping. Maybe you don't want more than 7 containers running on an instance. So when you start to see that every every instance in your fleet has 7, scale up. I mean, you can do all kinds of interesting custom things like that. So this is what it looks like for scaling above 75% memory threshold. It's really, really simple. When memory reservation is above 75% for probably more than one consecutive period, scale up. Application auto-scaling means scaling the containers, so scaling the service definition. As you're building a service, you can define you see up at the top, auto-scaling, and then the minimum number of tasks, the desired, and the maximum number of tasks. Just like with instances, minimum, desired, maximum, this is for containers, minimum, desired, and maximum. And it's tasks. So a task might be multiple containers. And again, this is always just going to be based on a CloudWatch alarm. So a custom alarm, this could be throughput from the load balancer is one of my favorite ones to do. I'll test an application, measure what throughput it's capable of, and then as I get to around 80% of that average, I will scale up. What do you have available to you for security? So with security, of course, with the instances, you'll need to be patching instances, which I hope means for you, you're going to adopt immutable infrastructure. So that might mean either baking your own custom AMI, build that into your automation. Packer is great for doing that. Or it might mean grabbing the latest version of our AMI. That's my preferred way to do it. I think once you've started baking all of the intelligence into the container, then the underlying operating system is really meaningless. So just use a generic one that's provided to you that you know is going to be compatible. So the AWS container, or the AWS instance for that is great. Patching containers. So as you're building your container, how do you know you're running the latest code? How do you know you have libraries that aren't vulnerable to certain, exploits? There are services that'll do this for you. Twistlock is just one. Aquasec has one. Cloud Passage has one. I can't think of, there was another one that I've been using. But build it into your CI/CD workflow. So this is just an example of Jenkins, for example, building your container. And then once it's built your image, it passes it on to Twistlock. Twistlock will scan it and figure out, I'm using whatever Ruby gem that's vulnerable for these 8 exploits. And it'll notify you of that. What's even better, though, is, an exploit may not have been discovered. And Twistlock can keep track of everything that you have currently running. And it'll know, as soon as a vulnerability is discovered, it can alert you that, hey, your front-end container is vulnerable to this. You should consider patching it. And so you can go in, update whatever pip, whatever gem, whatever library you need to update, and rebuild your container with a newer version. It also helps to minimize what you put in the container. So building small containers helps from a speed perspective. You have to download less, so your deploys will be faster. But also that sort of surface area that has to be scanned by Twistlock and alerted on is smaller. So if you're using less libraries, then there's less of a chance for you to be outdated and less of a chance for one of those to become vulnerable. So this is just an example of a Docker file that is about as minimal as you can get. We're starting from scratch. Does anyone build containers today that start from scratch? Awesome. What language do you use for that? Is it Go? Yeah. So Go and Java are 2 that are great for this. C. I actually have started using Crystal, and you can build scratch containers there as well. So anything that's compiled, especially statically compiled, consider starting with a scratch container and building from there. I don't know if you guys have also heard of or not, but multi-stage builds are pretty handy. So a lot of times you can have a big container with all of your development tools, and then you compile, and that compiled artifact can be copied into a scratch container. And so you can still have all the tooling that you need for tests, for everything, and then what you're left with is a single artifact. IAM roles, this falls into the security category also. You can bind IAM roles to container instances, but what that is going to do is it means every container running on that instance is going to have that set of permissions. So we actually don't like doing that. What we prefer is for you to bind IAM roles to the task. And that way, when the task launches, that one task has the permissions necessary. So you'd get isolation. If something compromises a different container running on the same host, it can't take over the credentials from the task that has the ability to write to your database, for example. So you get a lot better isolation by doing this. Monitoring and logging. CloudWatch, built-in, natively supported. You log the standard out. We can ship those to CloudWatch automatically. We have monitoring available for CPU utilization, for ALB request rates, error rates, latency, all the good stuff, all built in, available for you to use. If, on the other hand, you like using third-party tools, like, for example, Prometheus, very popular in the Kubernetes space. Maybe you have some Kubernetes, you have some ECS, you want to ship everything to one dashboard. You can do that with ECS Exporter. So this is just an open source project. And what it can do is export metrics out of your ECS cluster and into a Prometheus service. Logging with CloudWatch logs. The thing to note here is log configuration, log driver, AWS logs. That's all you have to set in your task definition. And by setting that, you're able to then ship those standard out logs to CloudWatch logs. If you want to do something more custom, you have additional log drivers available to you. And by using one of these, then you'll be able to configure that logging service. So this is what CloudWatch logs looks like. And of course, there are metric filters with CloudWatch logs. So a great example of this is tracking error rates. So I can actually extract out all of my 500s and track the rate of 500s using this kind of metric filter. And I can see that I've gone from, maybe with a deploy, I've gone from 0 to 24 per second. That's probably significant. I need to look at that deploy and figure out what's wrong and maybe roll it back. If you want to know anything about ECS, there is a GitHub project by my coworker, Nathan Peck. It's called Awesome ECS. Definitely check it out. It has links to all kinds of resources that you can sort of dive into and learn all kinds of stuff about ECS. One last thing I want to show you. Don't have Chrome running. ECSworkshop.com. I mentioned that at the end. Oh. I guess that doesn't come across the screen. There we go. So ECSworkshop.com is a workshop that I wrote. And what this does is it sort of walks you through building everything that we just talked about, using CloudFormation, but using a tool that generates CloudFormation for you. So the CloudFormation that you end up with is like, 15 stacks. It's thousands of lines of CloudFormation. But what you have to write yourself is maybe 10 lines. So it's awesome from that perspective. It's called Mu, and it's by one of our partners, Stelligent. It's an open source project. But what you can do is use this tool to build an entire ECS stack, launch your applications onto it. So I wrote some applications to sort of demonstrate running a front end and a couple of back end APIs. And what you get when you deploy this application is this graphic right here. So you'll see traffic flowing through your VPC, hitting all of your endpoints. Is it like what? I think. I don't know what the steg format, I've never heard of it, so I don't know if it's like it or not. But what this does is it actually generates CloudFormation for you. And at any point, if you feel like you want to walk away from this tool, all you have left is CloudFormation. So there's nothing There's no database that has to be maintained. There's nothing that ties you to continuing to use this tool. I can show you the console if you want. I don't have it on my screen here, so I'll have to look up. So, for example, this is a cluster that I've built using this tool, and I have 4 services deployed to it with 9 running tasks. It's EC2 based right now. When you do the workshop, you'll be doing it using Fargate. So you'll see, there's almost no difference in how you manage things. And then the tool itself, I said, was Mu. So it gives you kind of a developer experience too. So for example, I've deployed a front-end application here, and if I want to see the logs, I can just run mu service logs -f, and I'm looking at the acceptance cluster. It's like my staging cluster, and I can see the logs for my application. This is a Rails app, and it spits out errors from time to time. And I can see, traffic flowing, and this will just follow my logs. If I want to deploy the latest version of my container, there's a mu command for that. If I want to push a new image, there's a mu command for that. So all of this you can see and build for yourself using ECS Workshop, and I encourage you to check it out. It walks you through the prerequisites that you'll need, and everything that it shows you. There's a copy-paste button that you can just copy and paste this into your terminal. And what I wanted was for you to be able to get up and running very quickly without having to know a lot, and then be able to go back and deep dive. What did this build? Take a look at CloudFormation, take a look at ECS, take a look at CloudWatch logs, etc., and sort of dive in. Everything that was built here was what we talked about today. It's all best practices, and you can use this sort of as a model to try and follow. And then if you decide to adopt the tool into your own workflow, you can certainly do that too. I encourage that. But even if you don't, this will still give you an idea of how should it look. And you can have a best practices stack built. Yes, sir? Soon. The question is, when will Fargate be available in Central Europe? And the answer is soon. All right. All right, that's the end of my talk. Thank you guys for hanging in. And if there are any more questions, feel free to come hit me up. We'll be getting started in about 5 minutes with the next talk about EKS. Thank you.